Welcome to today's Explainer. We're going to be tracking something absolutely fascinating today, a hidden current, and it's a current that flows through literally everything. We're talking from the deepest, darkest oceans to the vast, sprawling networks of a forest and right into the silent patterns guiding the universe. We are, of course, talking about intelligence. But we aren't just talking about human brains today. No, we're completely rethinking the concept from the ground up to show you how this invisible force shapes life in ways we hardly even notice. You know, for centuries, we've kind of just measured cleverness using tests designed by humans for humans. Think about every standardized test you've ever taken in school. We really like to think we sit comfortably at the very top of the cognitive scale, but what if intelligence isn't exclusively a human trait, measured by filling in bubbles on a Scantron? What if it's a presence that shows up in animals, in organisms without a single brain cell, and even in the machines we build? Here is how we are going to break it down today. 1. Rethinking the human mind. 2. Animal geniuses among us. 3. Intelligence without a brain. 4. The power of collectives. And finally 5. Artificial and future minds. All right, let's jump right into part 1, rethinking the human mind, specifically the quirks of our own brains. To really wrap our heads around this topic, we've got to toss out the whole idea of an IQ score. The source material redefines intelligence in a really beautiful way. It calls it the strange ability to imagine, to solve, to adapt, and to create new possibilities from almost nothing. And when you frame it that way, intelligence becomes this universal survival tool, not just some standardized metric. It's the universe's ultimate problem-solving mechanism. But to see that clearly, we first have to realize how strangely our own human processor actually works. Take a look at what's actually happening right beneath our conscious awareness. It's wild. Our brain acts like this restless, constantly shifting city. When we dream, we aren't just, watching movies in our sleep. We are in a mental workshop, silently rehearsing survival scenarios without any real-world danger. And in deep sleep, your brain is actually physically rewiring itself, making tomorrow's thinking smoother. Even more fascinating is that your brain actually learns to intentionally ignore most of reality. It actively discards background noise to build cleaner, faster internal models of the world. But it doesn't throw everything away. Think about that gentle neural noise it preserves, that subtle underlying chaos. That noise is exactly what allows completely unrelated ideas to randomly collide and spark your absolute best, most creative moments. Which leads us to a truly mind-bending realization. Your brain actually predicts decisions before you're even aware of them. Fractions of a second before you think you've made a choice, your deep neural network has already leaned toward an outcome based on past habits and internal models. As the source so perfectly puts it, conscious awareness then arrives like a narrator who steps onto the stage just after the main plot twist. It just explains a choice that was already in motion. We're often literally just the audience to our own biological processing. Okay, moving on to section 2, animal geniuses among us. It's time to redefine cleverness. So, if our own minds are basically operating on autopilot, let's step outside ourselves for a second. The crucial point here is that human tests reflect human biases. We naturally excel at language, at complex metaphor, long-term planning, but when you test for subtle mathematical probabilities, pigeons consistently outsmart human volunteers who tend to get hopelessly swayed by gut hunches. And when it comes to fleeting visual memory, certain primates can recall the rapid positions of symbols flashed on a screen way beyond the capability of any human adult. Their intelligence isn't lesser, it's highly specialized by evolutionary pressures, perfectly tuned to exactly what they need to survive. To really visualize the sheer, staggering efficiency of nature, just think about a bee. A bee has to navigate wildly complex, busy gardens, figure out friend from foe, and remember pollen locations. And it can accurately learn to recognize individual human faces using a brain that is literally smaller than a single grain of sand. It extracts deep meaning from the tiniest fragments of perception without a single wasted neuron. When you realize that intelligence is just specialized evolution, you start to see it taking incredibly diverse shapes. An octopus, for instance, thinks locally. Its nervous system is distributed throughout its arms, allowing tactile memory and curiosity to solve complex puzzles without a centralized mind. Dolphins invent completely custom acoustic whistles to name unfamiliar objects. They're essentially creating a bridge between abstract thought and vocal expression. And ravens? Oh, ravens are amazing. They can look at a complex multi-step puzzle and mentally simulate several future moves without ever doing a single physical practice run. They are basically playing 3D chess in their heads.
Let's keep expanding this outward. Section 3, Intelligence Without a Brain. We're looking at alien problem solving.
So, what happens when you have literally zero neurons? It is mind-blowing to consider what life can pull off without a central control center. Trees share chemical warnings about insect attacks and pump nutrients through vast underground fungal networks. Plants use internal cellular clocks to actually anticipate dawn, adjusting their chemistry hours before the sun even rises. And perhaps the most alien of all, slime molds. When placed in a physical maze with food at the end, they spread out everywhere and then, get this, systematically withdraw from the dead ends. They literally store the memory of the correct path purely in the changing geometry of their own bodies. No brain, just adapting physical form. We even see this out in the open ocean. Jellyfish possess this primitive yet highly effective form of learning. When they repeatedly hit obstacles, the rings of connected cells in their bells and tentacles retain traces of that physical experience. They use that to adjust their future pulse strength and timing to avoid collisions. This completely flips everything we assume about needing a central processor to learn. There's no brain calling the shots, just a living web adapting to its environment. This quote really hits the nail on the head. It perfectly captures that massive shift in perspective we experience here. When we look at trees and fungi exchanging complex, context-dependent signals, we realize a brainless forest acts as a cohesive, thinking community. Intelligence doesn't need a skull, right? It just needs connection. Which brings us to Section 4, the power of collectives. We're talking distributed minds here. Let's zoom out a bit. What happens when thousands of simple minds merge into one massive, coordinated entity? Think about the engineering marvel of a termite mound. There's no master architect holding a blueprint. Instead, thousands of individual termites follow very simple local rules, based purely on scent and temperature. They instinctively move soil from spots that are too warm or damp. They remove stagnant air channels exactly where needed. Through countless tiny, uncoordinated actions, the mound behaves like a collective, self-tuning climate control device. And we see this distributed mind everywhere in nature, operating as highly adaptive living networks. Take ants, for example, drawing dynamic, real-time chemical maps using pheromones to perfectly optimize their foraging routes as conditions change. Or look at wolves. They coordinate incredibly complex tactical hunts through subtle shifts in posture, acting like a practiced, synchronized playbook without ever speaking a single word. Even coral reefs, which might just look like static rocks to us, negotiate resource distribution and share nutrients during periods of environmental stress. The collective itself becomes the intelligence. Finally, Section 5, Artificial and Future Minds, the New Frontier. For our final leap, let's push past biology entirely and into the abstract realm of artificial and future minds. Artificial systems are now acting as these really powerful cognitive companions. Because they aren't limited by our human attention spans or biases, AI models are uncovering hidden rhythms in ecosystems and spotting mathematical symmetries in distant stars. They can see the invisible threads connecting billions of data points that our human intuition physically cannot parse. They're expanding our understanding simply by highlighting connections that are just too vast or too subtle for us to process alone. We're seeing this evolution happening in real time with self-organizing learning systems. When engineers let robots adjust their own parameters through raw trial and error, the machines develop strategies that look completely alien to us. They might invent this strange, awkward-looking gait that actually conserves immense energy over long distances. By simply interacting with their environment, they uncover principles of physics and movement efficiency that were totally invisible to their human designers. So, what does this all mean? Well, it builds toward a hybrid future. As we integrate intimately with these tools, human cognition itself is evolving. I mean, digital storage is no longer just a hard drive. It acts as a literal external memory bank extending the capacity of our own minds. Analytical tools deeply amplify our ability to recognize complex patterns. Collaborative networks accelerate the pace at which our shared knowledge grows. We aren't being replaced by these tools, we are expanding. We're merging our biological intuition with artificial precision, forming a hybrid intelligence that stretches our cognitive reach into incredible new territories. We've seen today that intelligence is way more than an IQ test. It's this hidden, powerful current that flows through the shifting geometry of a slime mold, the custom acoustic whistles of a dolphin, the shared pheromone maps of an ant colony, and the vast, deep neural networks of artificial machines.
So, now that you know this current flows through absolutely everything, how will that change the way you see your own mind? Thanks for joining today's explainer, and keep exploring.